The Acme company manufactures widgets. The distribution of widget weights is bell-shaped with a mean of 60 ounces and a standard deviation of 9 ounces. Use the empirical rule and answer the following questions. So, and they ask you to sketch the distribution. So the empirical rule says that if something's bell-shaped or normally distributed, that 68%, and I'm not sure why it says 68.27 would have been that. I would ignore that. And 68% of the data will lie within one standard deviation. And that sounds kind of weird, but think of it this way. If I tell somebody that I live on Blackstone, no, let's say McKinley Avenue, and I live on McKinley Avenue, and I live within 1 mile of the college, that means the college is here. And I might be 1 mile to the left, or to the right. I'm sorry, I went in the right direction there, right or left. Or I might be as far as 1 mile to the left. So 1 mile to the right and then the so I live somewhere in this region, okay? And so that's what they mean when they say within one standard deviation is you go 1 standard deviation to the right and 1 standard deviation to the left, and you're in that region somewhere, okay? Between, these are your boundaries, and you'd be in between those boundaries. So that's shaded, that region that's in, now I have the bell shape distribution, and here's the mean. It is the tallest point on, in the distribution. And if we add 1 standard deviation, we get here. And if we subtract 1 standard deviation, we get here. So between here and here, 68% of people are going to be between here and here. So if we're talking about like men's heights, if the mean of a man's height is 5'8", that's the average height for a man. Well, I don't know. I'm not sure what it is. Maybe it's 5'9". I'm just using that number. But then, and if the standard deviation is 1 foot, which probably it's not, but if then this is 5'8" in the middle, and then 1 foot would be 1 foot taller than that would be 6'8". Probably it's not. And then one lower than that would be 4'8". So that I'm pretty sure that's definitely incorrect, but I'm just giving this as an example. Okay. So so that would mean that 68% of the men out there are between the heights of 4'8" and 6'8". 68%. Which I don't think so. I think a lot more percentage. There's a much bigger percentage is between those two. So, but that's just an example. Okay. So let's do this problem with the actual data that we're working on, and that is these widgets. We're dealing with the weights of these widgets, and they say the mean weight is 60 ounces. So let me see how we see that in the problem right here. 60, the mean weight is 60 ounces. So that means that this mu is 60. And then with standard deviation of 9 ounces. So we take this 16, this point right here is the mean, which was 60, plus the standard deviation. That's the sigma is for the standard deviation. So it's 60 plus 9. So that's 69. And then if we go one standard deviation below, that's the mean minus the standard deviation. So that's 51. Yeah. Oh, 51. Yes. All right. So what that would mean is it means that 68, because this is one standard deviation below the mean, that's one standard deviation above the mean. So the amount of widgets out there that are between 51 ounces and 69 ounces is 68. So 68% of the widgets out there are going to have a weight between 51 and 69. So the answer here, the 68% of the widgets lie between 51 and 69. And I knew that because 68% lies between within one standard deviation of the mean, and these would be the boundaries of if you're within one standard deviation of the mean. So then it asks what percentage of widgets lie between 33 and 69. So most likely 33 and 69 are probably exactly a certain number of standard deviations above or below the mean. So we just have to find out in 33, how many standard deviations below the mean are you if you're 33? Because the empirical rule can really only tell us percentages if they fall right on exactly a certain number of standard deviations below or above the mean. So we have to figure out 33. How many standard deviations below the mean is 33? So one standard deviation below was 51. If I take away another, that's what this notation means. Take away two standard deviations. If I take away two standard deviations, I'm taking away 18. So that's going to be 60 minus 2 times 9, and I do the multiplication first, then the subtraction. So it's 60 minus 18. So that'll be 70. Take away 10 would be 70. Sorry, take away 10 would be 50. Take away another 8 would be 41. Then this one is the mean. Take away 3 standard deviations. So 3 times 9, which is 60 minus 27. Or I could have just subtracted another 9 from 41. Which would be 33. Right? Oh, no. Yeah, 9 plus 3 would be, oh, this would be 12. Wait a second, this should be 42, I believe. Yeah, there we go, 42. Oopsie. And now if I take away another 9, now I would get 33, because okay. All right. So actually 33 is actually 3 standard, you see, we took away 3 standard deviations to get to 33. And 69 ounces, so 69 is 1 standard deviation below the mean, or above the mean, sorry. So they want to know what percent is in between here and here, because that's where this 33 is here and the 69 is there. Well, the empirical rule doesn't really tell us, exactly the amount between here and here, but we have to use some deductive logic. So we know that this is symmetric about the center here. So we have to just use some deductive logic. If this region contains 68% of the data, the red region is 68% of the data, then that means there's 34% on to the left of the mean, and there's 34 to the right of the mean within that red region. And then we know that there's 95%, I'm going to ignore that decimal, 95% of the data is between within 2 standard deviations. So that means outside the 68. So if I do 95 minus 68, so 27. So that means there's 27 in the blue regions, but it's half, there's the same amount of blue region on the right as there is on the left. So I take 27, I divide by 2, which would be, let me do this. 13.5. So that would mean that there's 13.5% of the data in here in this blue region, and there's 13.5 in this blue region. Then we also know that the in the blue and red regions. So if I take 99.7, take away the blue and red regions, that'll give me the green regions. So it'll be 2.7 divided by 2, which is strangely, it's 1.35 again. So in this region, and in this region, there's 1.35% of the data. Okay, so that was not directly told to us in the empirical rule, but we could deduct that because we know it's symmetrical about the mean, and because we just, it's deductive logic here. So we found out how much data is in each of these little regions. Now we just have to add all those regions together between the 33 here and the 69. So we have to add the 1.35 plus, so we're going to add this one plus that one plus that one plus that one plus, oh, that's it. All 4 of those, add them together, and we're going to find out that'll be the percent of the data between 33 and 69. So we just do that. Okay, I think it's 82.85. So let's just double check our answer. And good thing I double checked my answer because I made an arithmetic error over here. 99.7 minus 95 is actually 4.7. What was I thinking? I don't know how, like, randomly I make these random errors. Anyway, so that would change our, so I do 4.7 divided by 2 because there's 2 little green areas on both sides. So 4.7 divided by 2 is 2.35. So that's why. So this area is 2.35. And so is this side, 2.35. So let's try that one more time. I'm going to add all the areas together that are between 33 and 69. So 2.35 plus 13.5 plus 34 plus 34. And that's 83.85. And let's double check that, 82.85. All right. Okay. So that is the part the next part. And then they ask, what percentage of widgets lie above 42? Now, do be careful with this problem because some students kind of forget and you can't even see it on the picture, so that makes it harder. But there is actually data outside of 3 standard deviations. So you see, they have it colored green, blue, red, but there's actually another color here. And that is, maybe I'll try to use pink. This region is only a little bit of region, but there's a little bit of regions outside of the 99.7. And how much? Well, it's 100% minus 99.7, and then divide that by 2, and it'll tell you how much is in the little tiny pink regions. So find my calculator. Wait, oh, it's 0.7 or 0.35, right? Yeah, I'm sorry, it's 100%. That's all the area underneath the curve is 100% of the area of the data underneath the curve. And then take away the 99.7. So it's gonna be 0.3, but then divide that in 2, 0.15. So this area right here contains 0.15% of the data. So don't forget that when you're calculating this last part here. So they said calculate what percentage lie below 42, above 42. Above 42. So here is 42. It's kind of good if you find the mean, you draw the mean on, and then you keep adding the standard deviation or subtracting the standard deviation to find all of these spots. Like find 1 standard deviation below the mean, find 2 standard deviations below the mean, find 3 standard deviations, calculate those numbers already. And that way, when you do a problem like this, you can just look and find the 42 because I had already calculated that. That's 2 standard deviations below the mean, which is right here. All right, so find all the data that lie above that. So, I mean, that's here. Here's where we're trying to find above. So that would be from here all the way. Well, actually, that pink region goes on forever, but kind of get the idea that we're going to have to add this plus this plus this plus this plus this plus, and don't forget this little pink region that like I'm saying, that one is not even visible. So like they forget that 0.15. That's what happens. So you'd have to add up all of those regions, and that's how you'd find this answer. A faster way to do it would be adding these 2 below it, because you only have 2 numbers below it, and then subtracting that from 100. So that's what I'm going to do. Because that's called the complement. Everything except for the thing that you want to find, all the percents. So we could just find the complement that way, and that is a little faster. Okay, let's see. Because we know that all of these regions, all the pink, green, purple, and red have to add to 100%. So the whole area under the curve adds to 100%. So if I take what's beneath 42 away from 100%, then that should give me all the other area above 42. So I'm going to add 0.15 plus 2.35. And that gives me 2.5, and then I do 100% minus 2.5, and that gives me the 97.5. And let's just double check that, and that's correct. All right. Okay, I hope this video is valuable. Bye.